Okay. Yeah. Good afternoon, everyone. So myself, I'm Vijay. I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop Spark environment. So as part of today's demo, I'm just going to cover the following topics. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Yes, both are clear.
Yes, it's clear.
Fine, thank you. Right. So just so what is Apache Spark? What is Apache Spark? Why PySpark? Need for PySpark. And today we are using like Python and Scala for implementing this Spark, right? For example, like Spark Python. Scala language, right? PySpark features. Real life usage of PySpark. PySpark job market, right? So this is what I'll be covering as part of today's demo. What is Apache Spark, why PySpark, need for PySpark, PySpark, Python and Scala, the differences between Python and Scala, PySpark features, real-time usage of PySpark and PySpark job market. Yes. Fine. So what is Apache Spark? So before I go, like, let me say like evolution of our evolution, right, of Apache Spark. Evolution of Apache Spark. Okay. Spark was Spark was developed by Matai Zaharia in the AMP lab, Berkeley in the year 2009. Developed by in AMP lab in the year 2009, right? It was open sourced in the year 2010. It was donated to Apache Software Foundation in 2013, right? It was developed in 2009. It was open sourced in the year 2010 and it was donated to Apache Software Foundation in 2013. And what is Apache Spark? Okay. Apache Spark, it is an open source. It is an open source distributed cluster computing. Distributed cluster computing. So I can say like it's a cluster computing framework introduced by Apache Software Foundation, right? It is an open source distribution cluster computing framework introduced by Apache Software Foundation. So it is a general engine for big data analysis, right? Apache Spark, it is the general engine for big data analysis, processing and computation. So, for data analysis processing and computation, right? Fine. Why PySpark? Why PySpark? PySpark, I can say it's a Python API. PySpark is a Python API, right? Python API to use Spark, right? Yes. It's a PySpark is a Python API to use Spark. So it is, I can say it's an open source cluster computing which is used for big data solution, right? So PySpark is a lightning fast technology, right? It's a lightning fast technology that is designed for fast computation, right? It's a very demanding tool among the big data engineers, right? For data engineers to work with the bigger data sets. And PySpark used for running distributed SQL data pipelines, ingestion data, right? Okay, just 1 second. So PySpark used for distributed SQL, creating data pipelines, ingestion data, ingesting data into database, right? Distributed SQL and creating data pipelines, using data into database, machine learning, ML algorithms, right? ML algorithms. Graphs or data streams. Okay, in this way, many more, right? So PySpark used for distributed SQL, creating data pipelines, ingestion, right? Right, data into the database and ML algorithms and graphs and data streams. Okay, so I can say like need for PySpark. Why need for PySpark? Okay, need for PySpark. So large amount of data is generated offline and online, right? If you see today, like a large amount of data is generated offline and online. Today, if we talk, data is occupying multiple formats. It's of different types: structured, unstructured, semi-structured, structured in the form of rows and columns in structured format, semi-structured, which is not fully structured, unstructured, right? And some kind of images, videos, links. And the data contains, if you talk about the data contains some hidden patterns, unknown corrections, market trends, right? And customer preferences and other useful business information, right? It is necessary to extract valuable information from the raw data, right? It is to extract the valuable information from the raw data. So we require some more efficient tool to perform different types of operations on these huge data sets. So already we have got some various tools to perform these tasks on this huge data set, but these tools are not so appealing. So it is needed some scalable and flexible tools to crack the big data and gain some benefit from this. So PySpark is such a kind, right? Where, okay, so scalable and flexible. Fine. So what we do here, yes, sir. So previously we have got many tools available, but they are not that much of appealing, right? So we go for this PySpark. So the combination of Python and Spark would be the very efficient way for the world of big data, right? That's why Apache Spark community came up with a tool called PySpark. This is a Python API for Apache Spark. Say Python API for Apache Spark. So for big data engine is this the one of the best tool for processing the data and for data analysis. So if most of them have got a query in your minds like Spark to go with Scala or Spark with Python, I'll just differentiate between these two, right? Yes. Python, Scala, Python and Scala. If I talk like here, Python, right? Yes, Python. Scala. So if I can say Scala is the native language of Spark. Scala is the native language of Spark. Spark by default built by using Scala language. But today Python is mostly preferred for if kind of data analytics, machine learning, right? So Python has got many modules, right? So mainly like Python is dynamic typed. Python is dynamic typed. So dynamic typed language. Scala is static typed. Scala is static type. What do you mean by dynamic type and static type? See here, dynamic type. Python is dynamic type means, for example, no need to define that kind of what kind of data you are trying. For example, x equal to 10, y equal to 4.5, right? Yes. No need to say int x or no need to say float y, right? So what kind of variable x is? What kind of variable? In the case of Scala, we say like val x, val x, you say val x equal to 10, val y equal to, we have got val and var. In Scala we have got to define a variable, we got val y equal to 4.5, right? So here what kind of variable x is means what value you have assigned to it. You assigned 10 means dynamically integer variable is going to get created during runtime. What value, based upon what value you are assigning, based on that the variable gets created in Python, right? If you're assigning a float value, so we have got a function in Python, right? Like type of x. Type of x is integer. Why it is integer? Because you have assigned an integer value to it. Based upon what value you are assigning, based on that only the variable gets created. We no need to specify explicitly the type, right? Like other programming languages directly can say, but we have got a function type of x is int. Why it is int? Because you have assigned an integer value. Type of y is float. Why it is float? Because you have assigned a float value. That is what dynamic data types in Python. Not only this, for example, z equal to list of values 10, 20, 30. Type, right? Yes. Type of z, list type. Type of z is list type. So in this way, Python is dynamic type, Scala is static type. Yes. But if we can say Python is open source. Python is open source. And has a large community, right? Yes. It's open source and has a large community. Scala. A smaller community, right? Scala has a small community. Python advantages means Python has a great, like, powerful libraries. Python has powerful libraries for ML and graph algorithms, right? ML and graph algorithms. Less as compared with Python, right? Yes. $89,300 inbuilt modules Python has got, right, for various domains. 89,000 inbuilt modules for various domains. Python has got modules for various domains, right? But used only for Spark. Used only for Spark. Used only for Spark. So Scala is used only for Spark environment, but Python not only for this Spark, also used for various other applications like data science applications, animation applications, gaming applications, desktop applications, embedded applications, right? In this way, wide varieties of applications for Python today, even for web applications, right? But Scala mostly used for Spark. PySpark features. Now coming to this PySpark features, right? Yes. First feature, the main feature, what we say is lazy evolution. Lazy evolution, right? We see in Spark, in this PySpark, it's like lazy evolution. Lazy evolution, active evolution. Which is better means lazy evolution itself. Lazy evolution means just like a function, right? We define it. If you make a call only, it executes. Function, you define it, but if you call only, it executes. If you're not calling, it won't execute. Active evolution means immediately when defined, execution, it executes. Okay. So just like in PySpark also, whenever you define that flows, immediately they won't get executed until you perform some kind of actions, right? Then only they will be, then only they get executed one after the other, right? Yes. Lazy evaluated. And one more mainly, right? In-memory computation, right? Yes. The storage and processing, both you can see within the memory level, right? Memory level storage and memory level processing is going to happen in this PySpark. Means as compared to disk processing, memory related processing is much faster storing and processing within this memory.
Sir, lazy evolution, please could you explain? Sorry, I think I missed that.
Yeah, lazy evolution means, okay. Here, Spark data objects, they are not going to get executed until you make it. Just like a function, a normal function, right? If you make a call, then only it executes, right? If you're not making a call, it never executes. In the same way, Spark objects also, they are lazy evaluated immediately. For example, just observe this. Generally, if you write a Python, this is your Python code. This is your code. They've got some lines of code. So interpretation, line by line execution, line by line execution. In Python, we see like interpretation, line by line execution. We are going to happen. Statement by statement execute. But this Spark data objects, they won't execute until you make some kind of action. they won't execute, right, until you make some kind of actions. So later I demonstrate about what are the various actions. For example, flow one, the output is taken as input by the next one, and flow 2 output taken as input by the flow 3. Finally, this one, if I perform any kind of action on this particular, then only this entire flow executes. Until then, it is not going to get executed. That's what lazy evaluated. Immediately when defined, until you perform this action only, this entire flows executes. Otherwise, they are not going to get executed. So we need to perform action. So when action performed, this executing, this we call it as lazy evaluated. One output will be the input to the next. One output will be the input to the next. So in this way, when you perform some kind of actions, later I discuss about actions. What are the various actions? Okay. Fault tolerant. So powerful fault tolerance model, right? Yes. So you can see like data is distributed across multiple machines. Suddenly, if any slave machine goes down, right? If any machine goes down, then data is lost. And also what two things you see, data lost and also the task failed means job failed, right? The task is failed means the job is failed. So these things, how to overcome, like we have got powerful fault tolerance model where the Spark can recompute the things by itself and gives the result back, right? Just the fault tolerant, that is what I'll be discussing in brief later. So just as of now, if data is stored across multiple slaves, suddenly if any slave goes down, then the data, there will be some data loss to overcome the data loss, and the task failure to overcome the task failure also, right? So how it is going to reassign that, how it is going to recompute the things, not again re-execute, it won't re-execute, it will just compute the things, right? It has got some features for it. No need to re-execute from the starting if any slave is down, right? Fine. Persistence. One more feature is persistence. One is the important feature, right? Persistence means if you talk in Hadoop or other things, right? They are any transformations, we cannot reuse them. In Spark, we can reuse the transformations. For example, transformation 1, you applied, you got some output that is taken as input by the transformation 2. Transformation 2 output again, your output, this is input, right? Transformation 3. So this transformation 3 output, right, is used by multiple flows like this. Think that multiple flows are using T4, T5, T6, T7. Think here a bigger transformation is there. Means this output to T3, no need to execute all these previous things. Directly using T3, this output it can take, it can come, T4 can compute, T5 can compute, T6 can compute, T7 can compute, right? So directly we can take the output of this. No need to execute all the previous steps. Directly from T3 is ready to give that result. So using the T3, T5, T3, T6, T3, T7, you got a very big flow. T1, T2, T3, T4, T40. T40 is output used by multiple flows, right? So no need to execute all these 39 steps. Directly T40 output we can take and compute T41, T42, 43, right? In this way, multiple flows are using these outputs. Which output? This output. So this if you, we need to persist it, we need to persist it. So what is persist and persistence, everything, these are the technical terms in PySpark we'll be discussing in brief, right? But if it is persisted only, you can use it. So one of the persistence feature means making that output available to the next flows, right? That is what persistence, making the data object to be existing within the RAM so that it provides the output to the other flows. Yes. Lazy evaluated, in memory computation, fault tolerance, in persistence, and immutable, right? All these objects are immutable. The original data object is not going to change, that will remain same, but from that you are going to take the output of it and you are recomputing the next one. Immutability, right? PySpark lazy evaluated. So until you make some kind of actions, right, it's not going to get in memory computation, within the memory only storage and processing, right? And fault tolerance, if any, as they are machines, suddenly if any goes down, then how they are going to get computed, right, without failing the job. And persistence, right, we can make use of the already executed transformations. But in Hadoop, we cannot use those kind of things, right? But here in we can use it. Immutability, right? Yes. Okay. So I'll just all this I'll be showing you, right? In brief, we'll be discussing in our course. And real life usage of Python, PySpark, real life usage of PySpark. So mainly used in the commercial sector, right? Yes. Commercial sector. Real life usage of PySpark mostly used in commercial sector. It uses commercial sector uses Apache Spark, a real-time processing system. Real-time processing system, right? So if we talk about the bank and other financial fields are using Spark to retrieve the customer's social media profile, right, and analyze to gain some useful insights which can help to make the right decisions, right? So the information which is extracted, you can use for credit risk assessment and target ads and for customer segmentations, these things, right? So even you can see like PySpark plays a vital role in fraud detection used in machine learning tasks. So here in commercial sectors, right, used for retrieving customer social media profile and analyzing that useful insights from it, right? And secondly, for healthcare, today if you see healthcare, Apache Spark it is used to analyze the patient records along with their previous medical reports data to identify which patient is, for example, probably to face the health issues. So which patient is probable to face some health issues even after being discharged from the clinic, right? Yes. So some kind of observations. So analyzing the patient records along with the previous medical history, right, to identify what is the real issue, right? Yes. To talk about in entertainment industry, right? Yes. So entertainment industry, right? It's one of the largest sector which is growing, right? So it is the entertainment industry is which is growing towards online streaming. So it's going towards online streaming. So the popular online entertainment, Netflix, right? It is using Apache Spark for real-time processing, right, to personalized online movies or web series to its customers, right? So it uses it process approximately, right? It process approximately 450 billion events per day. It processes more than 450 billion events per day that are streamed on server-side applications, right? Okay, apart from this, for trades and e-commerce, right? For trade and e-commerce. Yes, the leading e-commerce website like Flipkart, Amazon, all these they use Apache Spark, right? For advertising, they are using Apache Spark for advertising. Okay, enhance the customer experience and optimizes overall performances, right? Okay, apart from this, where this PySpark, right? For tourism, right? Yes, tourism industry. So it's the tourism industry also widely uses Apache Spark to provide advices to millions of travelers by comparing hundreds of tourism websites. Okay, and also we have got a separate kind of component in PySpark, PySpark SQL, right? It's a module in Spark. So for integrating relational processing with Spark functional programming, right? So we can extract the data by using this SQL queries. You can use the queries such as SQL language, right? So these are some of the real-time usage of PySpark, right? So Spark compared with any other technologies, right? It has got some kind of advantages in memory computation as compared in memory computation. There are some other in memory computation systems like SAP HANA, but like Spark, they are not distributed like huge data storage and processing it right in quick time. Okay. PySpark features lazy evolution in memory computation, fault tolerance, persistence, immutability, right? Yes. Commercial sector, healthcare. So previously I was just discussing about the differences between Scala and Python. Python, right, today like for analytics and for machine learning, like Python is mostly preferred because Python has got features. Python has got features, right? Yes. Observe here why Python is preferred. Why Python? Why Python? Okay, there are many reasons, right? Why Python? Why them Python means? First thing is very less coding. Secondly, simple syntaxes, just they look like normal English statements. Simple syntaxes. Very less coding you see in Python, and very simple syntaxes look like normal English statements. You can say like hybrid features we see, right? The features what we have got in many other programming languages, everything we see in Python, like procedural oriented, object oriented, scripting, and modular, right? We can easily interact with Python, right? Interactive mode. Very less coding, simple syntaxes, hybrid features, interactive mode, right? Interactive mode means, for example, CMD. I'll type Python here if you got Python installed in your system. So just you can see this three statements, right? Three statements. You can easily interact with Python statement. I'm asking what is the value of 4 plus 3. It gives the response. For every statement, it gives the response. X has 10, X plus 5, X minus 2. sorry, x minus 2, right? Not underscore, right? X into 2, x to the power of 2. So in this way, x equal to hello, HELLO, right? Sorry, x equal to hello equal to symbol. There's a typo, right? Yes. X into 3 prints hello for 3 times. X into 5 prints hello for 5 times. Into 7 prints hello for 7 times, right? Yes. So in this way, like Python, we have got interactive mode, which you cannot see in other programming language. Many built-in libraries for many of these, right? Many built-in libraries. Many built-in libraries. We don't need to write codes. Has got many modules, 89,300 modules it has got. Modules consist of built-in functions, classes, variables, right? So not only for Spark, it is also for different other applications, right? So okay, so this is what why Python, right? Yes. So I can say PySpark is a Python interface for Apache Spark that allows you to tame big data by combining the simplicity of Python with the power of Apache Spark, right? Combining the Python with the power of Apache Spark. As we know, Spark is built on Hadoop HDFS and is mainly written in Scala. Hadoop is, that is what Spark is written in Scala. Both languages are excellent. So I'm not saying let's Scala. Both languages, Python and Scala, are excellent for developing these applications. To answer which language is best between PySpark and Spark. The Spark, if I say, means Spark with Scala. PySpark means Spark with Python. If I say normal Spark, it is nothing but Spark with Scala implementation. So if you're working on a small project with inexperienced programmers, right, Python is the decent choice. But if you've got a very big project, if you're working with a very big project, huge project that demands a lot of resources and parallel processing, Scala on the other hand, right? Scala and PySpark both perform equally, right? Both are equally used. But if you want to go for some kind of data analytics, data science kind of applications, Python will be the best choice for this data science and data analysis, right? Fine. So just I was giving introductory today, like what is Apache Spark? Apache Spark, open source distributed cluster computing, right? So it's got a very high speed, right? Yes, very high speed processing. And PySpark used for distributed SQL for creating data pipelines and for ingestion data into database, ML algorithms, graphs, and data streams. Difference between Python and Scala, right? PySpark features and real-time usage of it, and why Python, right? Yes. Okay. If I see the speed of if you want to see the speed of Spark, so there was a test conducted by Yahoo, right? Yahoo, to check the speed of various databases in the market. It has taken a table of 100 TB consisting of 1024 columns. Task. Sorting based on 16 columns. Time taken by the things, time taken, right? Yes. Time taken by Oracle, right? Oracle. That's taken nearly 3.5 days to process it, right? Yes. MySQL. It has taken nearly 6 days, right? And a Teradata, right? It's a specialized database used for data warehouse purpose, which can handle huge data, TBs of data, right? Yes. It has taken 4.5 hours. Netija, one more specialized database used for data warehouse purpose. Netija, right? Yes. That's just to taken 3 hours time to process the data. And finally, Hadoop, if I come to this Hadoop, right? Hadoop has just taken 3.4 minutes. Hadoop has taken 3.4 minutes, right? But Spark, you see, is 100 times faster. 100 times faster. Hadoop, right? See the speed of Spark. As compared to the other things, Hadoop has got a high speed, right? But as compared to the Hadoop, Spark is 100 times faster than so Hadoop. That's why today, like, Spark has got good boom. We want to see that we want to process the data. We want to see quick results. Data need to be processed quickly. We need to get quick results. So PySpark is mostly preferred, not only for this, for analytics, for machine learning, the other things, right? Yes. So PySpark is proven in the market, and a lot of jobs for this. So that's why job market for PySpark. And even if you talk like the salary package, yes, give me a second, give me a minute, right? I'll just come back to your queries. So if you see the salary package for PySpark also as compared with other technologies also, once you can check it in the Google, the jobs for PySpark and the salary package for PySpark, little compared with other technologies, you see some bigger packages for this PySpark. Yeah. So just before I go with your queries, right? Let me just any query related to this, right? Yes. A general query.
Sir, for big data development, do we need to learn both Hadoop and Spark or only Spark?
Yeah, one second. I'll come back to your queries. The prerequisites, everything I'll be discussing. Right. Yes. Charyulu. Yes, in the topics we are using PySpark for processing, right? Yes. So here, what is the course content? What I'm going to discuss as part of this PySpark, right? In brief, with multiple working examples, right? Yes, PySpark. Can you observe here? What is Apache Spark? Why PySpark? Need for its Spark, Python versus Scala. Real-time research, PySpark web application, PySpark, Spark session, Spark context, Spark RTD, parallelizing, repartition, broadcast variables, accumulators, PySpark RTD computation, right? Operations on RTD, like DAG style, directed acyclic graph, RTD actions transformations, RTD computation, steps in RTD computations, RTD persistence features, memory only, memory underscore SCR, disk only, disk. What is the difference between all this? How this persistence happens in all this, right? PySpark core computing, right? Fault tolerance model and different ways of creating an RTD, word count example, increasing the number of partitions, aggregating out structured data, groupings and aggregations, right? Single grouping, multi-grouping, multiple aggregations. Process of group by key, reduce function, various transformations, various actions and transformations. See, various actions and transformations, right? These are all the various transformations in which include some kind of actions also available. Whenever you apply action, right, you will, the output you are going to get is Python object. If you apply any transformations, you will get Spark object, right? PySpark SQL data frame. Making data structured case classes, ways to extract case classes, using function, using map with multiple expression, using map with single expressions, data frames API, and PySpark creating a data frame. So this one, data frames is one of the important topic in this PySpark. So creating automated data frame to pandas also we have got pandas data frame to pandas, struct type, row class, column class, select, collect, with column renamed, where and filter, drop and drop duplicates, order by and sort, group by, join, union all, right? Order union by name, UDF map, flat map for each sample versus sample by, fill null, right? Yes. Pivot partition by. PySpark SQL functions, aggregated functions, window functions, datetime, timestamp, JSON functions, reading, writing into JSON files, right? And some built-in functions of PySpark, when, expel, lit, split. We don't need to write huge codings, right? We have got functions for you that can be applied on your huge data, big data, right? Split, substring, translate, overlay, to date, to format, months between, explode, array contains, array list, array set, array map keys, map underscore values, right? Okay, PySpark struct, count, sum, average, row number, rank, dense rank, percentage rank, type link, from JSON to JSON tuple, get JSON tuple, right? Yes, schema of JSON. PySpark external sources, working with SQL statements, pure SQL kinds of queries, Spark and PySpark and Hive integration, and with MySQL integration, working with CSV, comma separated values, JSON, JavaScript object notation, transformations and actions, narrow wide transformations, addition of new columns, dropping of columns, renaming columns, addition of new rows, dropping rows, window function, writing data back to external sources, writing data back to external sources, and creation of tables from data frames, internal and temporary tables, right? And deployment modes, local mode, cluster mode on standalone and beyond, right? Application, PySpark application stages and tasks, drivers and executors, building Spark applications, pipelines, right? Deploying Spark in cluster and tuning them, performance tuning, and also some knowledge on this PySpark streaming components, integration with Kafka and PySpark MLlib, right? MLlib, machine learning library, right? This is what in brief, in depth, I'm going to discuss all this, right? Yes, the duration will be 2 months. In brief, we'll be discussing with multiple working examples, right? Yes. So means 10 weekends batch. It is 10 weekends batch means 2 months means you'll get 8 weekends. So 2.5 months, right? It goes with in brief knowledge on this PySpark, right? Now, if you've got any queries, you can go with your queries, right? Yes. So tomorrow also you can attend the same time with the same link to see more on this, right? It's not like any duplication to today's session. It will be some continuation, right? Yes. So just now you asked some prerequisites, right? Yes, some basic Linux knowledge is required, basic SQL knowledge is required, some basic Hadoop knowledge also required. But I can provide that knowledge of that basic Linux. I can basic SQL and basic Hadoop knowledge also. Just some like I'm going to provide some HDFS knowledge, scoop knowledge, and the basic of Hive knowledge, right? so that to understand these things. Basic of Hadoop distributed like HDFS, Scoop, and basics of Hive. Apart from this PySpark, what are my offerings means like basics of Linux, basics of basic SQL knowledge, and the basics of Hadoop like HDFS, basics of Hive and Scoop, right? These things. Yeah, you got some query was asked, right?
So for big data development, do you learn both Hadoop and Spark or only Spark?
Hadoop, that's what I'm talking about. There are some components like the Spark in Hadoop, like Scoop is required. You need to have the knowledge on Scoop because how you are going to pull the data, right? Data, it's one of the data ingestion tool, right? Scoop. So you are going to bring the data from different databases to this. So knowledge of Scoop and knowledge of Hive and knowledge of HDFS. So if it doesn't have knowledge, just I'll be providing you those, right?
Sir,
Yes.
yeah, once,
Pardon?
yes, sir. So my name is Raghavendra Charlu. So once we completed this PySpark, course, I can get proficiency into write, pipelines or complex transformations in Databricks, right, sir?
Yes, yes.
My intention is Databricks because I'm data engineering. I'm
Mm.
looking for that one. I want to upgrade in that. But in my organization, there are complex queries are running. So that I need good knowledge about PySpark. Is it a good choice for me, sir? Please suggest me, sir.
Yes, yes, definitely. That's the reason. It's not like nearly I'm spending nearly 60 to 70 hours, right? This course nearly it goes for 60 hours. It's not like 35 or 40 hours. 60 hours
Okay.
I'm really spending in brief, like the computations, data objects, and for Spark SQL kind of queries. Spark is PySpark SQL is there for pure
So
kind of SQL statements and also data frames. Many data frames APIs are there, means making the data structured and in the form of rows and columns and performing data frame APIs available. Apart from that, if you want like pure SQL kind of querying also it's possible, right? So after making the data into structured and creating temp tables, temporary tables. So how we
okay.
can do that, you will be learning in this course, right? How to make the data structured and creating some kind of temporary tables and performing some kind of pure SQL kind of statements.
So I
And
can
also,
handle any kind of pipeline situations, transformation situation effectively, right, sir?
so it's a data flow language. Spark or series. Spark is a data flow language, collection of sequence collection of pipes. The output of one will be the input to the next. The total in the total course will be discussing, right? It's a
Yeah.
pipelines, right? So once at the end, once if you trigger an action, the entire pipelines are going to get executed. 1, 2, 3 means flow. The entire data flow is going to execute from the root to that. So everything will be discussed. So it's the nature of Spark is a data flow, right?
Okay. Thank you, sir.
So you mentioned it's the PL/SQL kind of nature. So is it, I heard correct, PL/SQL, procedure language SQL?
No, no, not we are not using any kind of PLSQL here, right? No.
Okay.
Sorry.
This extension to the previous one, sir, may I know which tool you're going to execute, sir? In the sense that Databricks, or which tool you're going to show you all the examples?
So I'll be just showing you on this Databricks, and also like I have created one like image I'll be giving to you to the Google Drive. Everyone will be downloading and working on it, right? So
Yeah. Basically, you're going to execute in a Databricks environment, and I will show the examples, right, sir?
yes, yes, that also I'll be showing you in Jupyter Notebook.
Yeah.
How to write in within this Jupyter Notebook, right? Yes.
Yes.
I'm going
Both
to show
in
you.
the sense Jupyter and this both the
So
places.
I'm going to show you, and this Spark shell I'm going to show you, and in Jupyter I'm going to show you, and how to write the Python scripts and how to submit, right, the Spark jobs. I'm going to show you on that, and also like in this also, as you talked about Databricks, in that also. Okay.
Yeah. Yeah. Thank you, sir. Sir, I think already someone asked, what is the duration of timing, sir? 1 day, how many hours? Weekdays only, right? The sessions will be
Yeah,
how
yeah.
many hours?
So generally it will be like 3 to 5, right? 2 hours on Saturday, 2 hours on Sunday, 2 hours. But later, if I'm running out of days, I'll just extend it to 3 hours after, if I'm think that I'm running out of days.
Thank
Fine. It will be like a first, initially it will be
So
for
what is the course fee?
Initially, yeah, the course fee is 8,000, right?
So do you have any real projects so which we can do it?
So at the last, I'll be showing you one flow, right? The total flow, how it's going, right? Yes.
So it's mentioned PySpark. So someone needs to learn Python first. Yeah, he must have the conceptual knowledge of Python. Then only we can go for that. Yeah, in the same system.
So Python, okay, learning Python is not a big task, right? So it's a simple language, simple like just normal English. So just for 1 or 2 days before I start with the actual part, I'll be just giving the syntaxes of Python, right? How to define variable, how to define function, how to define collections, how to work with it. It looks simple only to understand. But still, if you are updating by yourself also, it's not a.
Thank you.
So, but before I go with this, I'll be just providing you the syntax of each and every functionality of Python, right? Fine. Sorry. Fine. So tomorrow also you can attend the session to see more on this, right?
Yeah. So yeah, last question. Is there any prerequisites like Python and SQL, some other like what all the prerequisites should be there?
So Python knowledge is required. Python knowledge, why? Because everything goes in Python, right? So Python knowledge you can have. But as I said, I'll be just giving some knowledge on this Python before I go with the practical, all the syntaxes of various Python functionalities. SQL or basic of SQL also required, basic SQL knowledge is required, right? So during the course, you will be seeing all those things, right? Basic SQL knowledge means, okay, like we have got SQL. If you want to work with SQL kinds of statements, we have got Spark SQL component is there. So I can convert the data into a table, and on that you can perform pure SQL statements, right? So basic SQL knowledge also required. Fine.
Other than this, to any other, sir? Any other knowledge is required?
Basic Linux knowledge. Basic Linux commands is not a problem, that I can provide you. Basic Linux, just I'll be discussing the basic commands of Linux. And basic Hadoop knowledge, I'll be providing that also. Basic Linux knowledge I'll be providing you. Basics of SQL, basic SQL knowledge. It's not a big thing updating with the SQL, basic SQL. All basics of SQL, basics of Linux, basics of Hadoop, basics of Python required, right, for this Spark, PySpark.
Thank you.
From when the regular sessions will start? Sir?
So batch. So today is just introductory session. Tomorrow I'll be just starting with the. Tomorrow it's from tomorrow itself. It's going to start, and I doesn't want why, because we have given the time, right? 10 minutes. So we are not going to waste any time, right? Already we have got a huge syllabus. You can see the syllabus, right? It's very huge. We need to cover a lot of things.
Yes, sir.
Fine. See, this is the course content. You will be getting to your mails, right? By today, you will be getting all this. What is the course content, right? We need to discuss a lot of things. Okay, fine.
Thanks.
From tomorrow itself, we will be discussing. From tomorrow only, I'm going to start with the basics, right? Tomorrow I'll just start it. What is a Spark data objects, how they are computed, basics I'll be discussing. Next week, right, full-fledged manner, I'll be just going with our full time. Right, we'll be discussing.
Not related to this, I had a question about the Hadoop classes which you're conducting. Do you have any plans to conduct them during weekends? Or any batch you are planning to start for them on weekends?
Already I'm running multiple PySpark batches in the weekends, right? Okay. Multiple PySpark batches. Okay, but Hadoop, no. Fine.
Okay, thank you.
Fine, right? So I'm stopping here if I'm done with the queries, right? So meet you tomorrow, same time at 3 p.m. with the same link to see more on this, right? Yes. So thank you all for your time. Thank you. Fine. Bye.
Thank you. Bye.
Thank you, sir.